Okay, welcome back everybody. Having a lot of fun with the dodgy connections on this lectern at the moment, but we'll persevere, and we need some internet connectivity because we need to look at assignment 2 and find out how to do it. So we're here for IFB 104, Building IT Systems. The topic is how to remember things, which is a useful thing to be able to do. But before we get to that topic, there's all sorts of housekeeping stuff. First of all, there's assignment 1. It's getting marked. It's taking time. We'll get there eventually. There is another multiple choice quiz this week, and you're lucky because you've got a whole 2 weeks to do it in, because there's the mid-semester break coming up next week. The other thing that's important about upcoming breaks is that there is a holiday on Monday of week 10, so it's immediately after the mid-semester break. And that has a big impact on anybody who would normally go to a workshop on Mondays. So what we're suggesting is that you just go to another workshop, either on Friday, i.e. tomorrow, or Tuesday and Wednesday of week 10. Last time there was a public holiday, we put on some special workshops. One person showed up, so it wasn't really worth the effort. So special workshop times don't seem to work, but if you are all rushing to a workshop that's not your usual one, do be aware that some of them are still fairly full. The ones early in the mornings and late in the afternoons are probably the best bet to get plenty of space. But given the confusion caused by the mid-semester break, keep in mind that this week's topic is covered on Friday, tomorrow, and then after the break on Tuesday and Wednesday, and after the public holiday. So it's a bit of a mix-up as far as this topic goes. The other thing that's on your mind, though, is assessment. Assignment 2 instructions are now online. I haven't been there for long, and they're 25 pages long, so you might not have had time to read them yet. So I better show you what the answer is. It's due, of course, 5 p.m. Wednesday, like every assessment item for this unit in week 13. And there's also a part B, just as there was for assignment 1, which comes out very late in the day. So if nothing crashes here, I'll be able to show you what assignment, what's it called? Assignment 2 is all about. First of all, there are instructions, which are there. And the instructions are worth having a look at because they've got this nice diagram somewhere in here. So, first of all, motivation. All about the Internet Archive. So if you're not familiar with the Internet Archive, you should be, because it's a very useful thing. The whole problem with the Internet is you go to look at an old web page, remember, from years back, and it's not there anymore. And that's the nature of the Internet. Things come and go at high speed. So there is this website called the Internet Archive, which allows you to go back and find old websites that don't exist anymore. So it scans the web, stores them away in an archive, and then you can retrieve them later on. It's a bit frustrating because you don't always find what you want, because it only occasionally takes a copy of something. It'd be very difficult to take a copy of the entire internet every day. So often the day of interest, there's nothing there. And the other thing that you notice as you do that is you find the web page from 5 years back that you were interested in, but all the links to that, all the links from that page are broken. So that's the other characteristic of trying to resurrect old web pages. And both of those things are relevant to what you're going to do for assignment 2, because you're going to build your own version of the Internet Archive. And it's going to look like this to some extent. So here's the architecture of this thing you're required to build. It looks a bit complicated, but it's nowhere near as complicated as you might think. And in fact, once you get your head around this thing, it can be done fairly easily. What you're doing is building the thing in the middle, this thing called news archivist. I thought the word was archiver, but if you look it up in the dictionary, someone who maintains an archive is an archivist. And so you're going to write a Python program called news archivist, which maintains a archive of old news stories or current affairs stories or anything you like, as long as it's something that gets updated on a fairly regular basis. So there's your Python program in the middle. There's your archive of old stories. Now, though it looks like a database in this picture, it's not. It's actually just a folder containing files. So it's a folder containing downloaded web pages that you've stored away, and now you're going to give people access to them. How do you do that? Well, you have a GUI. And so you have a tkinter front end on your program, just like the little test you've just done, which allows the user to say, I want to extract this item from the archive, the items being copies of old web pages. So there's the main functionality, the archive, the program that allows us to interact with the archive. When the user says, I want a document out of the archive, what your program does is it creates a new HTML document which summarises the contents stored away in the archive. So it doesn't take the old copy of the document out of the archive, it examines the document in the archive, extracts certain elements from it, sounds like pattern matching and regular expressions and stuff like that, and it generates a new HTML document. That new HTML document is your summary of, in this case, the top 10 stories for that particular day that the user was interested in a nice format. And you can view that extracted set of news articles in just any old standard web browser, such as Firefox or whatever you've got on your computer. That's the basic functionality of it, but there is one additional thing that your solution has to do. It has to be able to put stuff into the archive. So somewhere online there's a source of these news articles, and the user can choose to download the latest news and store them away in the archive itself. And by doing that, they're adding something to the archive. So that's all the functionality required is. Let me show you the actual solution. Hoping that my internet connection is still working. So first of all, this is, let me get rid of this, move that to the bin. Okay, so what I've got here, assignment 2 demo, this is what you would submit. You would submit something that looks like this, a Python program, which in this case is red because it's the solution. Any GIF, graphical interchange format files needed to support your tkinter interface. You might have noticed that tkinter only allows GIF images. So if you want to put a nice image into your interface, you need to include that file as well. But most importantly, that's the only image file you can supply. And the other thing you supply is your archive. And your archive is a collection of HTML files. So here we've got a bunch of HTML files collected over a week. So we need at least 7. From different days. Sorry, I'm just going to change this as well. I'm going to throw this one away, move to trash. Okay, so there's your basic archive. It's got 7 things in it. And there what you can browse in terms of old information, but you can also add new information, as we'll see. So what does your program actually do with this archive? Well, excuse me, you start it up by pressing F5, you hope, and it comes up with the GUI. So this is the GUI that we've got for our archive. Now, first of all, of course, you need to choose what you're going to archive. So we've done the pretty obvious, boring thing and decided to archive the ABC News for Queensland. But if you go to the instructions and look at the appendix up the end, there's tons and tons and tons of other places you can get information on the web. So don't copy our example, do something else. But this was a pretty obvious choice, as you would imagine. Our graphical user interface has a nice image. That was what we got out of that GIF file. It's also got a menu here. So this is actually a list of different dates for which I can extract news. And we've got some buttons to control it. Oh, and we've got instructions as well. Choose which day's news to extract. So you have to have all of those capabilities, but again, don't copy our example, come up with something better. Radio buttons might be a much better way of selecting the dates. Why not a pull-down menu? Anything that works, basically. You can design your own user interface. That doesn't matter at all, as long as it does the job of allowing people to extract things from the archive, view them, and put new things into the archive. Okay, so we've got our archive as a collection of files here. If I follow the instructions and select a day, which I've done, let's pick the 17th of September, that was last Sunday, and press the button Extract News, what it will do is go to the archive, find the old web document in there, and construct a view of that web document, which will pop up in this area here. It will appear in the same folder as the program that I'm running. So I'm going to press the Extract News button and cross my fingers. And as you see, it said news extracted from archive, and we've got a new file appeared here, abcnewsqueensland.html. Now, if I want to see that file, there are a number of things I could do. One of them is press this button called Display News. Display News will open up that file in my preferred web browser, which happens to be Firefox. So I press Display News, and after a short pause, up comes the news. Oops, I've lost it. Up comes the news for Sunday, 17th of September, as stored away in the archive. Now, what are the features of the page that's been generated here? Well, we've got a title for a start, we've got a date, we've got an image which reflects the contents of the page. That is not on my computer, that has been downloaded from the web, so it's actually a link to that image. We've also got a link to where we got all this information from. I'll go back to that in a moment. We've said who is maintaining the archive. In this case, it's Grimly Fiendish, but actually it's going to be you people. And as we scroll down the window, we start to get the news stories for that particular Sunday. So obviously, being Queensland, it's all about rugby, which means nothing to me. But there's stuff about NRL crowds. Whale watching was a big thing on Sunday. 2 different pictures of the whale. And again, all of these images are not stored permanently on my computer. It's downloading them through this dodgy Ethernet cable here as I view the page. Okay, and so we've got a whole bunch of stories that were current on Sunday or Saturday, going back a bit further, because we're going back in history here. So here's that famous white whale, lots of stories about it. Broncos beat Panthers, and that one's way back on Friday. So each of the stories has 5 features, I think it is. So, 6, I think. So we've got a number. This is the 10th top story on Sunday. We've got a title or headline. We've got the picture, actually a link to the picture. We've got the story itself. Broncos seal a spot in the preliminary final. We've got a link to the full story. So if I was to click on that, that would take me to the full story. And we've got the time at which the story was uploaded to the web. But all of this is old news. I can go back through the archive and keep bringing up old news items, but we also want to get new news. So if I can find my interface again, here's the interface. As well as extracting old news articles, I can say archive latest, which means get the latest news from online and store it away in the archive. And this is where I don't know what's going to happen at all. So if you look at the archive here, it's currently got 7 documents stored in it. And if I press this button that says archive latest, with any luck, another one should appear. Okay, we've got ABC News latest.html. Okay, is that the one I just downloaded? I believe so, yes. 11.14 must be. Okay, so that's the path for getting current news into our archive. If I want to see that news, I need to extract it from the archive again, so I'll press Extract News. Okay, news extracted from archive, happens really quickly. And then I'll display the news again in my web browser. Oops, that's the wrong one. Oh, because, stupidly, I didn't select which one I wanted. I've got to select Latest, Extract News and Display News. That's better, Latest Update. And good example of a really lousy user interface. Can you do better than that? I'm sure you can. So here's our latest news as downloaded just now. Malcolm Roberts, all about the citizenship thing, which is going on at the moment. One Nation Senator, more about rugby, why do we care? More and more, something about fruit flies, etc., etc. People on the dole, all this sort of stuff that worries you if you're a Queenslander, which I'm not. There's the latest news as it currently stands. I looked at this just before I started the lecture, and that story about Malcolm Roberts wasn't the top one. It was this one about the PNG and finals frenzy. So every time you click on, oops, what am I doing? Every time you click on this archive latest, it will store a new copy of the current news from the original web page in the archive. And basically that's all you can do with this particular implementation. You're welcome to improve upon it, add extra features, but that's all you need to do for this assignment. Now, the question is, how do you do it? We need to consider that. So you're generating a new web document, and if I do this, I think we can see the source. Yeah, okay, so this is the source for the web document that we've just generated. So this is what our Python program spits out. It creates this web file that is displayed by extracting all of the elements it needs to construct the top 10 stories from the archive. In fact, for our demo solution, we've extracted more than 10. And I noticed one before, if I can find it somewhere down here. That's the one. Look at this, QUT in the news. Making lithium-ion batteries not that hard, says QUT professor. I don't know who the heck he is, but he says that you can make lithium-ion batteries quite easily. But that news was way back on Wednesday, so this is going way back in the archive. We just want the top 10. If you want to generate more than that, that's fine. Not all of these websites will have more than 10 stories, so that's why we picked 10 as the number. But essentially, that's our file that's been generated. That's what it actually looks like as HTML source code. So you're writing a Python program that generates that HTML source code. I still haven't shown you where we got it from in the first place, though, and this is the tricky thing. So if you go to the top of our page, we've got a link which says this is the original source for our news. And if I click on this link, with any luck, it will take me to, slowly, it will take me to this site. This is where we got the news from. And notice how different it is. This is an RSS feed. So RSS feeds are websites that contain regularly updated information. It was slow because this is a big site. So this is ABC News Queensland. And as you can see, it's got tons and tons of junk in it. And it's got all these stories going backwards in time. Each of them has everything that we need for this particular assignment. So you want to find a website that's similar to this with all of these features. We've got a headline, a little paragraph summarising the story. We've got a link to the photos. So you don't actually include the photos in the stuff you download, you just have a link to them. And we've got a time. So a time when the story was entered in there. So this is not intended for human consumption. This is a website specifically designed for people like you to write Python programs to scrape. Scraping is extracting elements out of web pages, and these RSS feeds are web pages that are set up just for this purpose. So it's not intended for you to browse this web page. It's not very readable. If I want to see any of the images, I've got to click on these links and so on. But it has all the information I need to construct my own web page, so that's what you're doing here. Is this where we got all of the information for our archive from? No. That's the page that's delivered to Firefox. This is the other challenge for this assignment. If you look in the instructions, you'll see if you view this particular page on your iPad or some other tablet computer, it looks completely different. And if your Python program downloads this web page using URL open, one of the methods available for accessing online documents, it'll get something else yet again. Because these days, web servers are pretty smart, and what they do is they figure out who is asking for the information, and I'll deliver something which is customised to their needs. So in this case, I'm acting as Firefox, and it says, oh, if it's Firefox, somebody must be wanting to read this. So I'll deliver it in a human-readable form. If I'm using an iPad or smartphone, it says, oh, I'll produce a condensed version. If you have a look in the instructions, you'll see that you only get the headlines and the little story part in the iPad version, but you don't get the links to the images or anything like that. And similarly, if your Python program tries to download this, it gets something else yet again. So what your Python program sees, can I do this? I'm not sure. Let me just, as a quick way of getting there. Okay. Come on, come on, come on, come on. Yeah, okay, that's what I'm after. This is what's stored in the archive. It doesn't look like that at all. In fact, it doesn't look like anything much. Firefox complains about it and says, this is an XML file, but I don't know how to display it, so here's the source. So this is what gets delivered to your Python program. If your Python program asks for a web page, it doesn't get what you see in your browser, it gets something like this. That sounds bad. Actually, it's very, very good, because what's delivered to your Python program is a much simpler document than this one. This one has all sorts of formatting information in it, whereas this one just has the basic facts. So it's easy to extract information from it. So if you have a look at this, we've got a story here, Broncos beat Panthers, and that's between title tags in HTML easy to find. We've got a link to the full story between link tags, really easy to find. That's the great thing about using this as my source of information. Everything's laid out for me in a very easy to find format. So my Python program just has to search through this using some sort of pattern matching technique to find the various elements it needs in order to construct our news archive, which ends up looking something like that. So, given that your Python programs will get delivered something different from the thing you see in a web browser, how do you actually figure out what's going on with your Python programs? Well, we've given you a couple of tools with the instructions. One of them is called downloader. So downloader is a really small Python script. Let me just open it up quickly. There it is. So this is with the instructions, and that's the whole script. And all it does is download a web page using URL open. This is the thing you'll need for opening web pages. It assumes that the web page is in Unicode format, UTF-8. So it downloads the contents and decodes them in that format and spits them out to a file. So at the moment I've got the URL set to be the same one I've been using all along, the ABC News Queensland. And so if I run this little file, so let's run the downloader with this as my URL, it'll create another file on my desktop here with any luck. Okay, so I'm running this one now. And a little file popped up there, download.xhtml. Okay, so that's the file it downloaded from that web address. And if I open that one up in Firefox, I should get exactly what I saw before, if Firefox can cope with it. I crashed Firefox when I was doing this before. There we go. Okay, so that's the latest version of that page as delivered to a Python script. And that's what I would keep and store away in my archive for later use, because it's easy to find the various elements in that. There's the story we were just looking at. Hurry up. Malcolm Roberts sent citizenship queries to non-existent email address. And the various other bits of that story, One Nation Senator, blah, 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 blah. So everything I need is in there in order to construct what I was looking at before, but I think I've now lost. Where's my latest news that I constructed? Is it this one? Might not be, I can't remember now. Yes, latest up. Oh, there it is. Yep, that's the one I was looking for. So what we did was, given this, the thing on the right, we extracted the little bits of text out of that to construct this nice looking page on the left as a different looking document, obviously, but containing the same elements. The other thing that you have to do is to make sure everything looks nice. Your GUI should look nice. Your web pages that you generate should look nice. And in particular, they should be fairly resilient with respect to a couple of things. Firstly, changes to the size of the web browser window. So in this case, if I adjust the size of the window, you notice everything sort of still fits in reasonably nicely. So here's how it looks on a smartphone, all skinny. But I've still got all the ingredients there, and they all fit together quite nicely because the width of the text, the size of the photos and so on is all set to be with respect to the size of the window. So if I stretch it out, it still works just as well. So you should put some effort into designing your HTML documents so that they work nicely like that. And the other thing that could go wrong, although I don't have an example of it, is you have links to things that no longer exist. So remember I mentioned that about the Internet Archive before. One of the problems for the Internet Archive is that all the pages are interconnected, but if you've downloaded a copy of a page and it's got a link to something else you don't have, then you've got a broken link. And so your program needs to be robust to that as well. I can demonstrate that by pulling the Ethernet cable out of my computer, which I've just done, and trying to reload this page. And let's see what we get. I haven't tried this before. It's desperately trying to download all these things and is not finding them. So remember, the original web page here doesn't have all of these images and so on embedded in it. They're all just links to online copies of these photos. It's never going to start up now. Wait, let me kill that one off. Let me open it up again with the cable disconnected. Ugh, I've got too many things here. There we go. Come on. Oh, how is that? It's all still cached, unfortunately. Ah. Let me try once more. Come on. Come on. I knew something. This is the old problem of live demos. I knew something like this would happen to me. Ah, that's what I'm after. Okay, so if all of the links are broken, I still display something that's readable. So what you're seeing here is the stuff that's actually in my generated HTML document. You can see that it's got the basic elements, but it doesn't have any of the images because they were links. And it's saying here, sorry, image such and such not found because I've got the Ethernet cable in my hand. And similarly for all of the stories going down here. All of the images are missing, and if I click on any of these links, they won't take me anywhere. Problem loading page. But if I go back to my original page, it's still not too bad because we've put some effort into trying to make it look okay, even if some of the links are broken. So that's the other thing that you need to worry about as you do this exercise. All right, that's all I've got to say. That's much more than I wanted to say about assignment 2. Are there questions about assignment 2? There must be. No, that's amazing. I'm quite happy if there aren't, but I thought there would be. All right. No questions about that? So you do have to include links to where you got the information from. So that's listed in instructions as well. So a link to the original web page that you're getting all your data from, that should be up the top in the heading part. And for each story, there should be a link to the full story. So you'll find on these web pages there's always a link to the full story somewhere. So you should include that as well. So that does as referencing. Any other questions? Yep.
Will we get a copy of our HTML but
Nope. You have to figure it out for yourself. So you have to. So if you look at the instructions, sorry, I'm still fiddling with this broken VGA cable. If you look at the instructions, you'll see a list of things you should do, and a lot of them are quite independent of one another. One of them is design your HTML document. The AV people really don't believe me that there's something wrong with this cable, you know. I'll give them another call later on. Okay, so you have to design your HTML document, and you can do that separately from everything else. I wouldn't try to do everything at once. That's the main lesson here, because there's just several different things to do. Design the GUI and implement that. Design the HTML document that you spit out, and also figure out how to extract the elements from the documents that are in your archive. So those are 3 quite separate activities, and you can do them all independently. I wouldn't try to do this as one humongous program. Get each of those things to work separately, then put them together. If you try to do it all at once, you'll just get hopelessly lost. Any other questions? No? You've got plenty of time to do this one because we've got the mid-semester break next week. It's not due until week 13, yes? You already have. Actually, everything that's in this assignment we finished doing last week, up to this point. There is a part B. Yes?
So SQL is not taking services?
Not part A, no. If you look in the template file, you'll see that it imports SQLite. There must be a reason for that. All right, we all good on assignment 2? Okay, speaking of SQL, let's get on with this week's story, which is about, if I can get this to go, data. So a lot of what I was just talking about was about data, but this is data in a different sense. This is going to be data in terms of databases. And we're going to spend 2 weeks on databases. It's a topic that you will cover in other teaching units, including the database unit, which has 1,000 students in it each semester. So we don't want to go into it too deeply, but we do want to get some awareness of databases and what you do with them and how you use them, because we want our Python scripts to talk to them. So that's the interesting part. But we're not going to do that this week. We do that next week after we've learnt a little bit about the basics of databases and what they are and what they do for you. So much of what I'm about to say is really fairly generic stuff about SQL and SQLite, but we're going to use it in Python starting next week. But before I even get to that, I'm going to warm things up with some stuff about why we would even care about databases. I'm going to talk a little bit, and seeing the time, I'm not going to spend much time on it, briefly about saving data in files from our Python programs, why that's not such a great idea, and why we might want to use a database instead, and then we'll look more closely at databases themselves. So lists as ephemeral storage. There's a demo here, and I'm just going to run the demo and not actually show much about it. Let me get rid of that and go into the demos. Okay, so this is just by way of having an example involving lists and remembering things. It's called Breadcrumb Trail. And if I run the program, with any luck, something will happen. A little window will pop up with a turtle in it, and I can click in this window and the turtle will follow my clicks. So if I click here, the turtle goes up there. And if I click here, he goes there, and I can drive this turtle around the window for a while. And I can even try to draw a picture if I wanted to. A bit late now. And after doing this for a few clicks, in fact about 10 if I remember correctly, the turtle gets fed up with this. So I must be just about near the end now. And the turtle says, I've had it, I'm going home. I'm taking all my lines with me. So it goes back to where it started from and erases the lines along the way. You can just see a shadow of the lines as they disappear. What's the big deal about that example? The fact that the turtle remembered where it had been before. So it remembered all the coordinates of where it had gone. So how did we do that? Well, we use lists, obviously. So here's the program. It's a Python script. It has a variable called breadcrumbs. And this is a list of coordinates. Initially, the first coordinate is the home coordinate, 0, 0. And there's, down in our main program, we've got something called on-screen click, which you might have seen in one of the workshop demos. That's the thing that recognises mouse clicks in the drawing canvas. And whenever I click on there, it calls a function called next step. And where's next step? Next step is here. So next step gets, by default, the coordinates where the mouse was clicked. And what does it do? It says if steps left is greater than 0, steps left is a variable, initially 10. Then we go to those coordinates, and most importantly, we remember doing so by appending to that list the coordinates we just went to. So this is the memory part. And then we decrease the number of steps, and when steps left is down to 0, it says, I've had enough of this, follow breadcrumbs. And that's the bit that went back to the beginning. Follow breadcrumbs just says, for each coordinate, crumb, in the list of stored coordinates in reverse, so it has to go backwards, back to the beginning, then we change the turtle's colour, go to that coordinate and change the turtle's colour again. That's why the turtle was flashing on and off as it went back. So nothing significant about that program. It's just a silly demo to show that we can store information in lists and retrieve it and do something useful later on. The whole problem with this, though, is as soon as I do this and close that program down, all those coordinates are lost forever. I can never get them back again. So lists are, as it says here, a nice temporary or ephemeral form of storage for data items, but they only last as long as your program is running. As soon as the program finishes, all the data is thrown away. So they're not very good for us as a permanent form of data storage. We need something better than that, and we can come up with something better than that. We can, for instance, do what people have done for a long a long time, and that's save our data away in text files, because in previous lectures we've seen how to write data to text files and how to retrieve data from text files, and I will spend a little bit of time on this because it's worth remembering how to write and read from files, because that's part of what you're doing for assignment 2. So what have I got in the way of slides here? So the idea here is just to write your own programs to store the data you want away in text files and retrieve it later on. So using my cheat sheet here, let's write a couple of very small programs to do exactly that. Let's get this out of the way. So I'm going to start up, I'm going to do a very quick construction of a little program called text file writer. Okay, and there is another demo here I'm going to steal some data from. Okay, so here's some information about superheroes. What else would you talk about? So we've got a list of pairs of creation dates for superheroes. All right, so if you go back into ancient history, Superman was the first really prominent superhero in 1938, followed a year later by Batman, and then you get Wonder Woman in 1941, etc., etc. Captain Marvel was 1940, Black Canary, who probably most of you have never heard of, 1947, etc., etc. I just wanted some gender diversity in here. So we've got this information about superheroes, and it's vitally important to us. We want to save it away forever. So I've only got it in a list here in my program at the moment. So if I close this program down, all that information is going to be lost. So how can I save it? Well, the obvious thing to do is to store it in a file. So first of all, I'm going to run this program, F5, put it on the desktop. Okay, come on, come on. Save it on the desktop. Let me call it writer.py. So this is my little program. Does it run? Yeah, it seemed to run, nothing went wrong. So I've got the information in some lists, but they're only temporary. How can I store it away? Well, the first thing I have to do is find a place to store it. So I'll put it into a file. I'll call it text out. And I need to open the file. So if you've got a local file, you use the built-in open function to open it up. If you've got a web page you want to open up, as in the demos we just looked at, there's an equivalent thing called URL open. So in the case of a local file, you give the name of the file. If you're opening a web page, you give the address of the web page. Here I want to store this information, these birth dates about superheroes, in a text file. And I need to specify, since I'm opening it up, that I want to write to this file, not read from it. So we put in a W there. Okay, so that will create my file. Open file for writing. And if we're good corporate citizens, we would also remember to close the file again. Okay, close the file. And that's done with a method called textout.close, no parameters required. I can run this now and see if it works, and with any luck it should create a new file on my desktop. Function F5. It did, created that text file. If I open it up, there's nothing in there because I haven't put anything into it yet, but it did create the file. So there's my storage place, the place I'm going to put my valuable data about when these superheroes were born. So I have to now put the actual data about the superheroes into the file. And this is where I get stuck, because I have to come up with a format for storing this data away. So you'd be familiar with things like tab-separated files and comma-separated value files, .csv files, all in different formats, and they're all incompatible, because this is one of the big decisions you have to make when you're writing data into a text file. What format is it going to be in? So I'm going to write this data about superheroes one line at a time. That's a fairly obvious thing to do, but I need to separate the superhero's name from the date, and so I need to pick a separator. So a CSV file uses commas to separate things. Tab-separated file uses tabs. You can use whatever you like as long as it doesn't appear in the fields you're trying to save. So I'm going to use something that's totally different. Let's see what we can do. So write data to file. So I'm going to have a loop that says for, let's say, hero and date. This is a nice, easy way of doing it. in superhero birth dates. Why did I pick such a long name? Okay, and what I want to do is just write that bit of information, the hero's name and the date, into the file, but I have to decide exactly how to write it. So I'll say text out dot write, and what I'll write is, those tooltips are not very helpful, are they? I'll write out hero. Remember, hero is the name of the hero, Superman in quotes, so that's a string. So I can just write that out directly, but I have to convert the date into a string before I can write it out. You can't write out a number directly, you have to convert it into a string. And if I do it just like that, it's going to be the name and the date squeezed up against it. I need to put in some sort of separator to keep them apart. So I'll put in between them a colon. Why a colon? It's just an arbitrary choice. So this is my choice of separator, and when I run this now, it'll overwrite that file. By the way, that's another important thing about that downloader I showed you before. If you run it twice, you lose the first data that it downloaded because it overwrites everything. So by default, if you say, open this file for writing, if there's already something in it, it's gone. So beware of that. I'll run this program now. F5. Did I run it? Okay, it doesn't print anything. So I think I ran it. I can find out by opening up the file again. Oh, okay, and we've got stuff in here, but it's not quite what I wanted. So you can see it's written the data in there, and I forgot the thing I always forget. I needed to put a new line at the end of each of these lines. So I better put that in as well, because you don't get that by default. So I put in \n at the end. Okay, so I'll try it once more. Okay, it happens so quick you don't see much. Yep, okay, all good. And let me open up the file again. So we've got birth dates, and there we are. Okay, Superman 1938, Batman 1939, and so on. So I've stored my data away in this file. What about if I want to get it back again? Well, I need another program to do that. So I'll very quickly write another Python program called, naturally enough, text file reader. Okay, text file reader. And this time I'm going to open file, oops, can't type very well, file for reading, and again, close the file, always try to be nice and neat. How do I open the file? Well, first of all, I have to know what the file's name is, and I've already forgotten that, but it's in here, it's birth dates. Okay, so I'm just going to quickly cut and paste this bit of text to be quicker. Okay, open file for reading. Text in this time. So I'll open the file, give it a name, text in. I had to know what the file was called. I'll open it in, I'll open it in universal mode. That's the thing I always try to do, just to make sure I don't have to worry too much about line feeds. I'll be nice and close the file at the end. Text in dot close. Good-o. Let's run it and see if it works. Source must, I hate that. Okay, and I'll call it reader.py, save, okay, and nothing much appeared to happen because I didn't actually print or display anything, but it did successfully open the file and close it again. That's a start. And now I'm up to the next dilemma is I want to read the data, read and let's say print the data in the file. But in order to do that, I have to know the format in which the data was stored. In particular, I have to know that it's got two fields separated by colons. And if I didn't know that, I wouldn't know what to do with the data. I do know that, fortunately. So in this case, I can just say for each line in the text in file, what do I want to do? Well, for a start, I'm just going to print the line. So let's see if I can read in each line and print it successfully, and with any luck it should show up in the shell window. Hoping you people can see all this stuff. There we go, and it did show up, and a couple of things happened. Well, firstly, it's just the data exactly it was in the file with the colons in between, which doesn't look particularly nice. And also we got extra line feeds in here. Why is that? Because every line you read in using this approach has the line feed character or the new line character stuck on the end. So if I didn't want that, there are a couple of ways around it. Which way will I do it? I'll do it this way because it's sort of more obvious. I'll say no new line is going to be the line. This is just one way of doing this with the new line character. Remember, it's just a character. I'm going to replace it with nothing. Okay, so now I'm stripping off that new line character from the end of the line, and when I print the lines with the new lines, the line feeds at the end removed, hopefully I'll get something that looks a bit better. Okay, so now I don't have those extra new lines all over the place, but I still haven't formatted the data in a very nice looking way. So what I want to do is divide up the name from the date and display them separately, and I can do that because I know they're separated by colons in this case. But I have to know that in order to do what I'm about to do, which is to say name and date assigned. I don't know if I can do this actually. I'm making this up as I go along. Let's see if I can do this. Split on colon. Okay, so what I'm doing is applying the split function, which returns all the individual fields based on a particular separator in a string, and I'm hoping we get 2 fields out each time because I'm assigning that to name and date. And what I want to print is the name followed by a space and an open bracket, followed by the date and a closing bracket. All right, so I want to make it look much better than what you're seeing there. With any luck, this will work. And it did, amazingly, first time up and around. So I've extracted the data, I've been able to distinguish the names from the dates, and I've stored them all away. Oh, sorry, I haven't stored them away. I stored them away previously in the text file. I've extracted them from the text file, and it all seems hunky-dory. But there are downsides to doing this, even though it works. So let's have a quick look at some of the downsides. Okay. So it's easy to read from text files, it's easy to write to text files, but there are limitations of doing this, and 2 fundamental limitations. One is the one I've kept emphasising, which is the fact that in order to read the data back, I had to know what format it was written in, so I had to decide in advance what the representation of the data was, in this case colon-separated fields, and if I don't know that, I might not be able to retrieve it effectively. So there's no actual clear definition of the data structure that's used in storing the files. And as the image on the right suggests, the other thing is it's completely insecure. Anybody can get at this data now because it's just text. And so any text editor will open up that file and allow you to get at the data. So they're the big limitations of using this crude brute force approach to storing your data. So what we need to do instead is use databases. Databases solve both of those problems. So a database is a way of securing your data in a form that is hard for other people to get at because databases normally have access controls built into them. And it uses a standardised representation so that you don't have to worry about how to save the data. It's all done for you behind the scenes. You just have to worry about using the data. So a database technology does both of those things for us. And databases are accessed via something called a database management system. So we're going to use one today. SQLite. It has a number of different purposes. First of all, it allows you to define the structure of the data that's stored in the database. It then allows you to put data into the database. So these are 2 quite distinct things. What is the structure of the data? And after you've defined that, put the data in, and then, of course, extract it later on. And the way that's often done in a lot of databases is using something called SQL, Structural Query Language, which is an old-fashioned relational database language, but it's still very widely used, and so we might as well use it here. And so accessing a database might involve using a standard off-the-shelf database management system, which has its own graphical user interface. We're going to use one of those right now. Or you can write your own programs to talk to the database management system. That's what we'll do next week. So these are both ways of accessing the database. The database is way off to the side in the diagram because we don't even need to directly see that, and very often a database will be online somewhere. It'll be on a remote server. We're actually nowhere near the data, but we have an interface to the data in the database. I'm just wondering what's coming up next. So in order to do that, we need to learn a few things we haven't seen before in this unit. We're going to have to learn a language called SQLite. And we're going to have to learn a new tool, a thing called, believe it or not, the DB browser for SQLite. So the analogy is exactly with the stuff we've done before with Python. Python was our language, IDLE was our development environment. Here we're going to use another language, SQLite, and another development tool, the DB browser for SQLite. It's got the most awkward name I've ever known. Okay, so we need to learn how to drive this tool, and we need to understand the language. So we're going to use SQLite as our language for manipulating the database, I should say, and we'll use this particular tool to do so. And we're going to take a break in a second, but before I do that, I just want to show you the database browser that I'm talking about. So it looks like, if I can find something in all of this mess, I don't need any of that at the moment. Okay, and it looks like, okay, I'll just double click on this. That'll be the quickest way of getting there. So in your demos, you've got some databases defined, and the tool that opens up those databases is this thing, DB browser for SQLite, a database browser for that particular relational query language, SQLite. And so this is our development environment if we wanted to develop SQLite code. This is a very nice environment to play with because it's very simple. If you use things like MySQL and some of these serious database tools, they're quite complicated, but this one, as the name suggests, is a lightweight version and it's quite easy to use. This is a database I've already defined, so the database is already here. It's got some tables, and we'll talk about this stuff after the break. It's got a table called actors, a table called bad guys, a table called good guys, and a table called series statistics. I can look at the data in those tables by going here, and it says actors. We've got various actors and the roles they played and the TV series that they played those roles in. Okay, and we've got something which is more important over here, which is execute SQL. So we can write SQL-like scripts and execute them to perform certain actions, such as creating tables, putting data into tables, and most importantly, querying those tables. But I think you're all hanging out for a break, so before we get into database concepts, let's take a 10-minute break, and when we come back, we'll look more at how to use this tool and what it's capable of. Right, don't breathe. Okay, welcome back. We better move on. So somebody just asked me a question which I shouldn't have explained. Where did I get that stuff I was just showing you? So in your demos, there's a whole bunch of stuff, but there's a thing called classicozsci-fi.db. .db means database, and so it's an SQLite database. And it's called Classic Oz Sci-Fi for a reason, because some people are very eccentric and have an interest in weird things like old TV shows. You would never have guessed that in the 1960s Australia produced its own science fiction series. Instead of Doctor Who and Star Trek, we had Phoenix 5, the Interpretaris, Vega 4, the Stranger, all sorts of stuff. Very hard to find on the internet these days. You can get copies of Phoenix 5 episodes from YouTube, but I've never managed to track down a Vega 4 or an Interpretaris. Why do we care? Well, for database purposes, this is actually a useful source of data because these 3 series shown here all featured characters in common. So it was actually a continuing story across 3 different series. And that means we can have some databases where there are the same entries in different tables. Just before we get into it, what did it look like? Well, it looked like this. So these are the spaceships from Phoenix 5. You've got the Phoenix 5 itself and the Astro Scout, the little shuttle. Very Buck Rogers-ish. And these are the good guys. So we had heroes, of course. You've got to have heroes. And importantly, they've got assistants in the form of computeroids. Computeroids are computers that can move around. They've got legs. And so in the first 2 series, the Interpretaris and Vega 4, there was a computeroid called Henry. Same computer in the 2 different series. And in the last series, Phoenix 5, there was a different computeroid called Carl. What about bad guys? Similar sort of thing. You've got bad guys in common in different series. So the bad guys are evil-looking humanoids or mad scientists. But importantly, the character Zodian appeared in 2 different series. He appeared in Vega 4 and Phoenix 5, but portrayed by different actors. So this is all good fodder for creating databases with various features. So, given that fascinating information that I've just conveyed to you, I have already set up this database called classicozsci-fi.db. And when I double-click on this, it opens up that database in the database browser for SQLite. Hopefully that's readable to people. And there are really 3 tabs here that are important to us. The one that says database structure, which tells us what the structure of the database is. The database is a collection of tables. So where are my database concept slides? If we move on a bit here. So we're talking about relational databases. Sounds much more grand than it really is. A relational database is just a set of tables, the same sort of tables you would see in a spreadsheet. So you've got tables, they've got rows, they've got columns. And people use different terminology for them. Tables are sometimes called schemas or relations. Rows are sometimes called tuples or records. Columns are often called fields. And types of... So each column has data of a particular type, and that's also sometimes called a domain. But it's really nothing more than a spreadsheet-like table or a collection of tables. So in this particular database, we've got 4 tables, one for the actors, one for the bad guys, one for the good guys, and one with statistics about the series itself. And I don't want to go through this in a huge amount of detail, but I want to show you enough to give you some idea of what a database is, and then we'll look at creating a new database from scratch, which will give us a better introduction to the SQL language. So first of all, each of the tables has various constraints associated with it. In a database table, so let me, well, there's one on the screen there, I guess. In a database table like that, it's important that there are no rows that are duplicated. So you never have the same data in 2 different rows. That's a basic feature of databases. Also, the order of the rows and the order of the columns is not relevant. So although they're normally displayed in a particular order, there's no significance to that. You can only put 1 value in each of the cells. And yeah, that's about it. So you can have, for instance, there's Zodian again. Zodian appeared in the series Vega 4 and Phoenix 5, and he's a humanoid, but the fact that his name appears twice and his species appears twice doesn't matter, because the entire rows are still distinct because the series is different. So there are no duplicated rows in this particular table. The other thing that's a feature of this particular database is in, say, the good guys table. And by the way, all of these are just screenshots taken directly from this thing, so you're not missing anything by me not using that. So it's just a screenshot taken out of here. You know, this is the actors table. Tells you who played which parts and in which series. Okay, so there we go. But you can see in, not that one, if we pick another table, bad guys, you've got species null, and in good guys, species null. In other words, we just haven't put data in that cell, and you're allowed to do that unless a constraint has been put into the description of the table that says you must supply a value here. What we're assuming in this case is that if the species is null, they're a human being. So that's our default. So we're not putting something in to say Tina Coolbrick is a human being. We know that she's a human being because there's nothing in the species cell. So null is just a special value, which means nobody's put any data into this cell as yet. Nothing deeper than that. What else is there to know about these things? Primary keys. This is important. So once we get around to querying the database, we have to be able to pick particular rows of interest. Now the question is, how do we identify the rows? Well, we identify the rows via the primary key. Now the primary key is just a column that you've chosen that is unique in all of its values. And so you can identify who you're talking about by choosing a particular value. So in the case of the actors, all of the actors have different names, and they all only played one part, so we can use actor as the primary key here. But you can see that the character, or the part of Zodian, was played by two different people, Eddie Heppel and Redmond Phillips. So that entry appears twice. Zodian appears twice under the part column, but it doesn't matter because the name of the actor is still distinct. So in this particular table, we can use the actor as the primary key to uniquely identify any row in the table. So that's what you would normally hope. You've got what's called a simple primary key. If I need to find a row, I can just find a row in this table via the actor's name. But that's not always the case. Primary keys are sometimes a little bit more complicated because they may be a combination of columns. So here's the bad guys table from our database. It's not very big, but it's got the name of the bad guy, their species, and the series that they were in. And in this case, if you look at the name column, the first one, Zodian appears twice. So that means we can't uniquely choose a row by saying, I want the row with Zodian in it, because he's there more than once. And if we tried using the species column as our primary key, it wouldn't work either, because humanoid appears a couple of times and computer appears 3 times. Similarly for the series table. So there's no one column that uniquely identifies a row. So what do we do in that case? Well, in that case, we choose a different primary key. We make the primary key the combination of 2 things. In this case, if we pick the name and the series, that will uniquely identify any row in the table, because Zodian in Vega 4 is different from Zodian in Phoenix 5. So primary keys are normally just one column, but if it's not a column with unique values, it has to be 2 or even more columns. But the primary key is quite important because it's the way you access particular rows in the table once you start querying the database. And there is another concept which will come up briefly, and that's foreign keys, where you've got 2 different tables, but they have columns the same. So in the case of our sci-fi database, we've got a table called actors, and so it's got actor, part, and series. We've got another table called series statistics, which tells you what the series was, what year it started, what year it ended, and how many episodes there were. And in this case, series is the primary key in the series statistics table, because there are only 3 entries, Phoenix 5, Vega 4, the Interpretaris. But it's not a key in the actors table, but it can be used to link those 2 tables together, because it will allow us to link, for instance, the actor with the number of episodes they appeared in, or the actor with the year in which they started playing that particular part. So foreign keys are important when we want to join data from 2 tables together. And actually that's one of the most important things about a database. A database is not just looking up stuff that we've already stored away, it's about trying to get new information out of the data that's been stored by reconstructing that information in creative ways. I'm wondering what's coming up next. Okay, basic SQL statements and tools. So, if you want to, you can play around with this particular pre-packaged database. But we won't learn too much from doing that because it's all been done for us before. What I wanted to do was create a completely new database from scratch and look at some of the things we need to do in order to do that. So basic SQL statements and tools is going to show us how to create a database where one doesn't exist. And in our collection of demos, there are these other things here with .sql at the end. These are SQL scripts. So remember I said SQL is the language for manipulating a database. And these scripts are again just plain text, but they do things to the database when we execute them. So SQL is an executable language, just like Python, but instead of doing computations and calculations, it looks up or maintains a database. So we need another obsessive example to motivate our creation of a new database. And we talked about superheroes before, so we better do them again. So we'll look at setting up a database of superheroes. But of course, we go back to the golden age of DC superheroes, none of that Marvel stuff or nothing new. So we go back to the 1940s and we look at the original important superheroes, including characters such as on the right, Captain Marvel, who nobody remembers anymore, but he was the greatest superhero of his time, outselling Superman back in the day. So we want a database with these heroes in it. And we're going to create it from first principles this time around rather than just opening up a pre-packaged one. So what we need to do in order to do that is we need to have a bit of an understanding of either how to drive the tool or this SQL language I keep talking about. And I'm going to emphasize doing things using the SQL language because that's the way we can get the database to interact with Python programs next week. So you probably have already heard of SQL, Structural Query Language. It's been around for a long time, very widely used, and it's used in serious database applications. SQLite, the one we're using here, is just a subset language. It's a smaller language. It's a bit easier to play with. And it does have some weaknesses, though, because I mentioned before one of the important things about a database is that it has access control. It prevents people getting access to data when they shouldn't. But the SQLite system doesn't do that. It just, instead of having the database on a remote server somewhere where it's safe, the SQLite database is just a file on your machine, which means anybody who can get access to your machine can also get access to your database. So SQLite is not as secure as a real SQL implementation, but it does the same basic job. And it consists of two parts, just like SQL itself. A data definition language. This is how we define what are the tables and what are the columns in those tables and so on. And then once we've done that, the data manipulation language. It's all part of one language, but it's like in two parts. Setting up the tables and then manipulating the data in the tables. So we've got this tool that I briefly showed you before, which allows you to create and manipulate databases, but the reality is it's just running scripts in the background. So all the work is actually done in the SQL or SQLite language. The tool is just a convenient interface for running scripts. And let's see what we mean by that, by actually doing something. Let me get rid of that. So I'm going to start up the database browser thingy again, if I can find it. There it is, SQLite browser. So this time I'm not opening something that's predefined, I'm just starting it up from scratch. And when you do that, you get a blank slate like this and a few tabs. And so there's not very much I can do at this stage. Everything I click on is empty. There's just nothing in here. But if I want to create a database, I can say new database. So there's a button here that says exactly that, create a new database file. So I'll create my new database file. It's asking me where to put it. It's going to go on my desktop like everything else does. I'll call it superheroes, if I can type correctly, .db. DB is the default extension. I think it recognises some other extensions as well, but we'll use DB. Save. Okay. And so the very first thing that happens is a window pops up. So it said, OK, I'm creating a new database for you. What goes in it? And so it wants to know what tables go into the database. So this first window that pops up is edit a table definition, create a new table. So I need to give a name to the table. I'm just trying to think what is a good name. Well, I'm going to copy my example from my cheat sheet. We're talking superheroes. What's the one thing that superheroes all have? Secret identities. So we'll add a table called secret identities. So secret identities, if I've typed that correctly. So there's my table name. Now, table also has columns. So I need to give names to those columns. They're referred to as fields, normally, in database terminology. So when it says add field, that's asking me for the name of a column. So I can say add field, and then I get a little prompt up here, which allows me to edit the default name field 1 to something else. And I better type in superhero. Okay, so this is my first column in the table, and I need to give it a type. And so I've got a small collection of types to choose from. It could be an integer, it could be text. I have no idea what Blob does, real or numeric. So I'll make it text because I want to put the superhero's name there. And I've got a few other buttons that I can press here. One of them is primary key, PK. So PK means I want this column to be my primary key, the one I select rows using. So I'll press PK. Okay, so PK is going to select this as my primary key, and I wouldn't want to leave nothing in this column because I don't have a superhero's name to work with. So the other one I can click is not, meaning not null. So you must supply a value for the superhero's name if you're going to insert a new row into this table. And that's normally all you really need. Now, I'm hoping you noticed every time I clicked on a button just then, some text showed up down here. What's showing up down there is SQL. This is the language I've been talking about. And as you can see, it's fairly easy to read. It says create table, secret identities, and in round brackets, superhero is text and is not null. And then below that it says primary key is superhero. So this is what these buttons really do. They just create a script that we can then run to set up the table in the database. The other thing I need to put in this particular table is another column or field, which is, of course, the superhero secret identity. So if I can successfully double-click on this, and I could type the word secret identity. Okay, secret identity, I'll also make text, but it's not a primary key. Can we leave it null? Yeah, I guess we could. Maybe not a good idea, but I'll leave it like that for the moment. So I've now specified what I want in my database. I want a table called secret identities with two columns, superhero and secret identity. They're both text, but the first one is the primary key. So if I press OK, what it will do is just run that script. So I press OK. The script has actually run now, and in this view, the database structure, I've now got a table, secret identities, which has two columns, superhero and secret identity. They're both text and so on. So I've created a table. Or have I? In fact, I haven't, because what I'm working on here is a local copy of the database. If I want to save the work I've just done, I need to click on this button, Write Changes. This is what's known as committing my changes to the database. So it's another important thing about databases is that when you're using a tool like this, it's working on a copy of the database's data. And if you want to save the data back into the database, you've got to commit the change, or in this case it says write the change. And up until the point I do that, I can always revert the change. I can undo what I've done. But after I've committed it to the database, I can't undo it any further. So in this case, I'll say write changes, okay, and hopefully it's put that table into the database. I can find out by going into here, browse data, and it says you have a table now called secret identities. And it's got these two columns, superhero and secret identity, but they don't have anything in them. So if I want to add something into the table, I click on new record, or in other words, new row. So click on this, and again it pops up with some default values. But I want to put in a real superhero's name here, so I'll put in Superman and secret identity, which is, notice its default value here is null, because I said that could be null. I could leave it out, but I won't, of course, because we all know that Superman is Clark Kent. Okay, and again, I haven't actually made that change to the database yet. but if I click Write Changes, it will indeed happen. All right, so at this point I've created a database. I can close this thing down. Do you want to save the changes? Yes, I do want to save the changes. They're all saved now somewhere. There it is, superheroes.db. So it's just a local file on my desktop in this particular case. And if I open it up again, with any luck, I'll get back to where I was. So I've still got my secret identities table, and if I've still got my entry that Superman is Clark Kent in that table as well. So I could go on like this using the graphical user interface to slowly, one step at a time, populate the database. And that would work for a small job. But if you've got something complicated to do, particularly if you've got hundreds of records that you want to enter or something like that, it would be great to have a script do that for you. And that's where the SQL language comes in. So the tool is helping us run scripts in reality, as this slide says. But what about actually running scripts? So we need to understand the language used to maintain the database. So in the full SQL language, rather than pressing the button Create Database, you can run a script which has in it Create Database Classic Oz Sci-Fi. Or you could create a table. Rather than pressing those buttons that said Create Table, Add Fields, I could write a script separately in, say, a text editor and run that script. So I think I've shown you everything about that particular script. So you can do the job either through the GUI or by running scripts. And what I'm going to do here is show that I can get a lot of work done just by running a predefined script. First of all, I'm going to delete this particular record. Why am I going to do... Oh, no, I'll leave that for the moment. We'll see what happens. But what I want to do now is execute a script that I've defined before. So here's one called Create Tables. So Create Tables is my script for setting up all of the tables I want in my superheroes database. So not just secret identities. I want to have stuff about birth dates and powers and abilities of each hero, their enemies, their allies, their nicknames, their vulnerabilities, all sorts of things about these superheroes. So just to keep things neat, I'm going to get rid of this table that I created before, if I can. If I can remember how, I think I can delete this table like this, I'm not sure. Browse table, modify table, delete table. I right-clicked on it and it says I can delete the table. Are you sure? Yeah, I'm sure, because I don't want that one. And so I'm now back to the very beginning. I've cleared out the database. But what I can do is open up this script in the database. If I can find the right button, Open Tab, Open SQL file, that's the one I'm looking for. And if I can find in all of this mess, Create Tables.sql, open it up, and I'm now in an editing environment. So this thing I've just opened up here is that text I opened in my text editor, but it's now loaded into a little syntax-directed editor, so you can see things come up in colour, so that they're a bit easier to see. And I can now execute these statements, create table nicknames, create table vulnerabilities, and so on. I could execute them all at once, or you can execute them individually. So there are two buttons up here. One of them means execute just this statement, so that's the one on the right. So if I put my cursor on a statement and press that, it'll just do this statement. Or if I press this one, it'll execute all of these statements at the same time. The other thing I should have pointed out before is the separator for statements is a semicolon in this particular language. So it's a language not like Python at all, uses semicolons to separate statements. Layout doesn't matter. None of that stuff about indentation or anything like that matters. So it doesn't matter how you lay out this text, it'll still do the same job. So it's a different kind of scripting language, but it is still a scripting language that does a particular job for us. So what I want to do is run this script for this particular case. Hang on a second. I'm just trying to make my window a little bit bigger. I can't remember how to do it. Haven't done this for a while. Let's not worry about it. Let me see if I can change my preferences just to make the text a bit bigger for you. Where are we? General, database, I can't see it anywhere. Here we go. Font size, editor font size. Okay, so let's go up a few notches. Okay, that's better. You might be able to read that a bit better. So there's my script. It says create table identities. It's got 3 columns in this case. Create table birth dates, create table powers and abilities. If I look in the structure of the database, there's nothing. Tables 0. But if I run this script, with any luck, it's going to create all those tables for me. So I'll press this button, which means run the whole thing, and I get that wonderful message, not an error. I don't know why it says that, but that's good. If you don't get an error, that's a good thing. Now, it didn't look like much happened, but in fact it did create all of those tables associated with our superheroes. Allies, birth dates, enemies, identities, and so on. It also allows me now to browse each of those tables to see what's in them, but of course they're all empty. So I've got all these tables, but I haven't put anything in them. So this is the data definition language. I'm defining the structure of the data to say that there's a table called powers and abilities, which has 2 columns, a superhero and their power. So that's all good stuff. What about populating this database? Well, you saw me do an example before where I took a table and I said new record, and it prompted me and said what do you want to put into the different cells for this new record. But once again, I can save myself a lot of effort by executing insert statements that have already been predefined. So the way of inserting a new row into a table is called insert into. And you say something like, in the case of our old sci-fi database, insert into bad guys being the table, the values, Neptunus, humanoid, Phoenix 5. And in fact, Neptunus was another occasional bad guy in Phoenix 5. So in that case, that was a table with 3 columns, and we specified what goes into each of the 3 columns. But you don't have to specify a value for every column. So in the case of good guys, it's also name, part and series, if I remember correctly. But I don't want to put something in the middle column, so I've just specified which columns I'm going to populate. Insert into good guys, name and series, the values, Earth Space Controller, he's the boss, and Phoenix 5, but I'm not putting anything into the middle. I think it was the species column. So insert into is just a statement for adding a new row to a table. Alternatively, you can do it in the GUI by clicking on new record, and that will also add a new row into the table. But I've got another one of these things defined somewhere that allows me to create a insert a lot of data into the database. So if I can find my script, where is everything? Okay, here we go. Demos, populate tables. So this is my script for inserting data into the database. So as it says there, this script inserts data into the database. I still don't know why I can't make this window any bigger. It's driving me crazy. Okay, so this is just a series of insert into statements. The first one says insert into the identities table in these columns, superhero, secret identity, real name, these values. Superman is the superhero, Clark Kent is the secret identity, but of course he has a third name because he comes from Krypton, and so Kal-El is his real name. Whereas Batman is really Bruce Wayne. So in that case, the superhero is Batman, Bruce Wayne is the secret identity, and we just leave the real name null. And we're allowed to do that in this particular table called identities, because if we look back at the database structure, identities is a table which has 3 text fields, superhero, secret identity, and real name, but there is no not null constraint on the second 2 columns, so I'm allowed to leave either of those null. If I had a constraint there, I wouldn't be able to do that, but I can in this case. So this script is just a long series of insert into statements, which will populate the database with all sorts of information about the superhero. So keeping in mind that at the moment, every table I go to just looks empty. After I've run this script, it will populate, I think, every table by the looks of it, so we'll get lots of data into our database, such as here are all the enemies of our superheroes. So once again, it's all set up for me, so all I have to do is press the button, say execute SQL, and I get the message not an error again, which is a good thing. So not an error means something happened. If I go back to browse the data, sure enough, we've now got stuff in the various tables. So we've got all the stuff about enemies in the enemies table, secret identities in the identities table. What else have we got? Powers and abilities far beyond those of mortal men in the powers and abilities table. Okay, so we've got stuff about Superman and Captain Marvel there. We don't have something about every superhero. We don't have all the information that we could, but we've populated a lot of tables with a lot of data here. So this is the data manipulation language side of the language. Data definition language, define what structure the tables have. Data manipulation language, put data into the tables. Or, as we'll see, take data out and change data. Okay, so we've created tables, we've populated them. Oh, and I've completely forgotten to write my changes back into the database, which I've now done. As well as putting stuff in, what can we do? Committing changes, that's what I forgot to do. And more important than that, though, is once you've got stuff in your database, you want to query it. I'm just going to skip ahead a little bit because we can also, oops, oh no, I'll come back to that. So querying data, of course, is the main thing that you do with databases. You put the data in there and then you spend a lot of time querying it, and that's why the language is called structural query language. Most of the time is spent querying things. So we've now got a nice database full of information about superheroes, but what can we do with it? Well, we can open up another script here. Maybe, yeah, I'll just do that, I guess. Being a bit short of time, I'm just going to run these predefined scripts rather than trying to write anything from scratch. But query database is a series of what are called select statements. So select is the query part of the structural query language. And so select means select particular columns from a particular table, and often where those columns have certain characteristics. So if we look very briefly at these slides, so if you say select every star here is a wild card, nothing to do with regular expressions, which means select every column from a particular table. It does the same job as just going into the Browse Data tab. It gets everything out of the table and shows it to you. And what it returns is what's called the result set. The result set is itself a table, which comes back from querying the database itself. So that's probably the simplest query you could imagine, just give me the whole table. But you can then start putting constraints on what is returned. So, for instance, you can divide the data up vertically by selecting which columns you want. And you just name the columns. Select series and number of episodes from the series statistics table. There are other things you can do. You can change the order in which the results appear by saying things like order by number of episodes. And with our science fiction database, we'd get this result. As well as splitting the data up vertically by columns, we can split it up horizontally by rows, or select horizontally by rows, by specifying as a Boolean expression the characteristic of the rows we want. So in this one that's on the screen at the moment, it says select all the columns from the good guys table where the series name is equal to the Interpretaris, the first of our 3 science fiction series. So the result set returned in that case is just those rows that have that characteristic from that table. What's coming up here? And you can have all sorts of Boolean constraints on what you want returned. So the example on the left here says, I want 2 columns, series and year started from the series statistics table, but only where the year started is between 2 values, 1968 and 1970, inclusive, as it happens in this case. And you can also have patterns as well. Select all the columns from the actors table where the actor's name is like JU%. Percent is the wild card in strings in SQL. So you can see we've got lots of different syntax here in these different languages to confuse you. And another one, select actor and series from actors where part equals Zodian. But we haven't actually got the name Zodian in our result set because we didn't select the part column. So if we go back to the live database we've got here, so we've got our database, we've got a bunch of queries here. And so each of these queries you would execute one at a time. You wouldn't execute all of these queries at once, you just get a mess back again. So there's a collection of queries here just to illustrate certain things we can do. For instance, if we choose to execute this first query, it says, give me all of the columns from the enemies table. And when I press this button, and I'm pressing this button on the right to say only execute the line the cursor is currently on, press execute current line, as the tooltip says, I get a result. It says 8 rows returned from that query. So if you look at those rows, you can see there are 8 rows here. They are enemies and the corresponding superheroes, and that's actually all the data that's in that table, because I said give me everything out of that table. If I go back to browse data and look up enemies, it's exactly what was in the table. So I said give me all the columns and all of the rows out of that table. So it's not a very interesting query. But this is not the table itself. This is what's called the result set, the result of executing the query and getting something back. Next one's a little bit more interesting because it says select friend from allies, and the allies table looks like this. So this is the whole bit of data. It's got the friend. Jimmy Olsen is a friend of Superman, Perry White is a friend of Superman, and so on. But I only want the first column, the one that's called friend. So the query in this case, select friend from allies, will give me back just that first column. So that's the result I get, one column containing those particular characters. So that's slicing it by columns. What about slicing it by rows? So here we're saying give me all the superheroes where their birth date was before, strictly before 1940. So who was born before 1940? From the birth dates table, let's have a quick look at the table itself before running the query. So that's what the birth dates table looks like. Batman, Captain Marvel, Superman and Wonder Woman. Which one of them, or which ones of them were born before 1940? Well, we find out by executing this query. And when we do that, we discover both Batman and Superman were. Everybody else was born either during or after 1940. So these are some venerable superheroes. And the constraints on what gets returned can be much more complicated, such as in this one. Query number 4, select all the columns from powers and abilities where the power is like, and then there's a pattern we're looking for, but it's not like the regular expression patterns, just to confuse us. It's a different kind of pattern. It says we've got a wild card at the front, the word speed, and a wild card afterwards. So we're trying to find superheroes who have the power of super speed, and when we execute this query, we get this one. Superman is faster than a speeding bullet. Captain Marvel has the speed of Mercury. So it's just the fact that the string speed appeared under the power column that got those two selected. But if we look at the original table once more, powers and abilities is there. There's much more information in there about Captain Marvel's many powers. A few more queries in here. I think these ones are all very similar. Oh, there's a sorting one. We can sort the superheroes by birth date and do some other things. This is the one that I really did want to briefly mention, joining tables. This is more than just querying a single table. You can also query 2 or more tables and join the information from different tables. So there's an example here from our science fiction TV show database where we're joining some information together. But let's have a look at the example that's in here. So this is one where we're trying to match up superheroes' nicknames with their vulnerabilities. So some of the superheroes have nicknames, some of the superheroes have vulnerabilities, but that bit of information is in different tables. If we go back here, vulnerabilities, Superman's vulnerable to kryptonite and Batman's vulnerable to bullets. But if we look under nicknames, we've got nicknames for various superheroes. Superman's the Man of Steel, Batman's the Caped Crusader, Captain Marvel is the world's mightiest mortal. So the information we want from this query isn't in any one table in the database. It's in 2 different tables. So we want to match up the superhero's nickname with the vulnerability. And we can do that via the fact that they share a key in those 2 tables. The tables both have superhero as a column. So superhero allows us to find out which superhero has which nickname. What was the other one? It was vulnerabilities, which also has superhero as its first column, but their weakness is or the vulnerability is the second column. So can we join these two tables together? Yes, we can, but we have to do so by being careful to match up the superhero values to get a meaningful result. So if you look at this particular example, it says select nickname and weakness from nicknames and vulnerabilities. So I'm selecting one column from each of two different tables. If I did that, I'm going to put a semicolon here. Okay, so that's all I'm going to do. I just want nickname and weakness, two columns from two different tables, and I just want that as my result. It's not going to produce the result that I would like because it gives me all of this. It says the Man of Steel is vulnerable to kryptonite and bullets. Well, he's not. He's invulnerable to bullets. The Caped Crusader is vulnerable to kryptonite. No, he's not. Batman can pick up kryptonite in his bare hands and it doesn't worry him. So what we've done here is we've just merged the data from the two tables, but we haven't done so in a meaningful way. What we need to do is put in another constraint to say, when you join rows from the two different tables, make sure you're talking about the same superhero. And that's what this little additional constraint is down the bottom here. It says where nicknames.superhero, so in the table nicknames, the superhero column is equal to vulnerabilities.superhero. So only match up rows where you're talking about the same superhero. And if I now run this with that constraint added to it, I get a meaningful result at last. So the Man of Steel, the nickname, is vulnerable to kryptonite, Caped Crusader is vulnerable to bullets, and no other weird answers show up. So when you're joining data together from two tables, you have to be careful to use the keys to make sure you're joining it together meaningfully. Now, I know I'm out of time and you're keen to get away, but I'm nearly near the end anyway, because there's not much else that we can do at this point apart from update data. So you can change things in the database by executing an update statement. And an update statement normally looks something like this. Update a particular table and set a value, a column, to be some value where a condition holds. So in this case, the character Henry, the computeroid who is in Vega 4 and the Interpretaris, I've looked online and I cannot find out which actor played the part, no matter how hard I try. So we originally had in our table that the actor was unknown, and I want to change that to uncredited. So one way of doing that would be to say update the actors table and set the actor to be uncredited in rows where the actor's value is unknown. So it only affects that particular row in the table and nothing else. I know I'm out of time, but I do have a script for doing that to our superheroes. Stuff, where is it? Okay, update tables. So, this is the one that's going to make a few changes to the vulnerabilities table we were just looking at. So, in fact, it's actually going to add a column to the table, vulnerabilities. So add an effect. What is the effect of the weakness on the superhero? So that's a new text column. So this is another data manipulation language statement, alter table, meaning you can alter the table to add a new column. And there's another pair of update statements here, which say update the vulnerabilities table and set the weakness to be green kryptonite where the superhero is Superman. Why? Because those of you who were around in the 1950s would know that there are lots of different colours of kryptonite, not just green kryptonite. And similarly, set the effect of kryptonite to be loss of superpowers. And here's another kind of kryptonite. Red gold kryptonite gives Superman amnesia, but doesn't take away his superpowers. So we want to insert a new row into that table. So if we go back to the browse data table vulnerabilities, you can see it's got two columns, two rows, and just very basic information about Superman and Batman. And if I run this script, it's going to add a column and change some of the data that's in there. So I'm going to run this whole script now. And I get query executed successfully, go back to browse the data again, and sure enough, we've now got a new column, effect, on Superman of the various kinds of kryptonite, and we changed kryptonite to green kryptonite and added an entirely new row. So we can do all sorts of manipulations, not only to the data that's in the tables, but the structure of the tables as well after they've been created. And the very last one, before everybody runs away, is just to delete stuff. So you can, oh, I haven't got a slide on that. You can also delete rows and delete tables entirely. I thought I had a slide, I didn't. All right, that's all I've got. Next week we'll come back and we'll look at, no, not next week, the week after, mid-semester break next week, we'll come back and we'll look a bit more at SQL and in particular how it interacts with Python. Oh, that's helpful.
Today.
I'm just going to find out, am I still... Yep, okay. Stop capture.